Hi, this is Luke Robbins, and I'm going to demo my game engine. So let's get started here. First, we're going to take a look at this thing in action. We've got 4 of each type of object for demo purposes. We've got 4 ships up top. We've got 4 pyramids, then 4 diamonds, then 4 cubes at the bottom. And these it's not exactly a very pretty coordinated thing, but I just wanted to show a couple ways of kind of how I could get these things kind of moving in a dynamic way. So we get some of these guys rotating around and swinging, and with different transformation and rotations. And so here are our game objects, just to give you kind of a brief overview. So now let's walk through it, and I'll demo some features once I get to that part of it. So first, we'll get started by looking at our game objects. So over here we've got our .h, where we've got things like our various rotations, scale, which can be used for some of those modifications when we're trying to get things to rotate, our model, and our graphics object. In game object, we can set all of those based on what we're given, within game.cpp if we want to modify them. We can see here we can set different scaling, translation, rotation, and then use those to create that world matrix. So game objects, creating, transforming them with those, getting those matrix transformations together, and then it's GL states that's controlled in their individual graphic objects classes. So if we go in here, we'll see things like GL enable, like face culling and front facing, things like that. And yeah, so each of them have their graphics object, which can be of various types. If it's color, if it's constant color, flat texture, texture light, wireframe, things like that. And I'll delve into that a little bit deeper as we get to that point. If we want to take a look at the camera, adjusting and setting attributes, we can do that. So first, let's get a look at what the camera looks like. And so if we start over here, we can move forward, we can move backwards, we can move side to side with the arrow keys, and then with kind of our corresponding WASD keys, we can rotate around to get a different view of this, and hopefully not get too seasick. So that's kind of a look at the camera. And also the camera, we have multiple cameras in this world, so if I hit C, it will swap to a different camera view. And I think I have 3 of them in there right now. So if I hit C again, 1, 2, 3, 2, 3. And I can just keep swapping in between those guys. And that is because I don't use individual cameras, but what I do have is I have camera nodes. And these guys have a V up, a V pause, and a V look at, which I can use to kind of set that data. So the cameras are managed by a camera manager, which actually only has a single instance of camera, but what it does have has these camera nodes. And so if I want to switch camera, I can call that, and what it'll do is it will just iterate to the next camera node in the list, and if it hits the end, it will just wrap around to the beginning again, and then it will set that data. So that we're kind of looking in the right way, and we don't have to have different cameras. So that seemed like a more lightweight way of doing that than having multiple cameras. So setting attributes, moving it. Frustum calculations is just in camera.h. I mean, this is probably going to look pretty familiar for the Frustum calculations. So those guys and some of that math, I just didn't even want to bother changing because it was working and I didn't want to break it. So supporting multiple cameras, switching between cameras. So next, let's take a look at textures. So we've got a few textures on these guys, as we can see, just the typical ones we demoed. So we've got bricks, and we've got duckweed, and we can swap those by hitting T, and that will swap all of the textures. And so kind of like the camera and the camera node information, I've got kind of that linked list of textures owned by the texture manager. And what's happening when I'm hitting that is that each of those textures is being moved to the next one in the linked list. So what will happen is that each texture node, it will be set, based on that information. So actually, the thing is, I had to access all the texture objects that belong to the Game Object Manager to do that, so I'm not thrilled about having texture-specific code in the Game Object Manager. I'm wondering if, texture being so fundamental to so many that's okay. But for right now, what it does is it iterates through, and for each node in that list, it hits change texture, which just gets the next texture in the list owned by kind of the texture manager by name, and then sets it to that, so the next time around it starts drawing it with a different texture. So that seemed to work out pretty well. And in order to do that, what I ended up doing was allowing for graphic objects to be split up into two branches in the Game Object Manager. So I've got color root and texture root, and so those both live underneath the main root, and so it's essentially two different branches. And then I can just call that on everything in the texture root, so just starting from there with the iterator. So I can swap textures, the same object, and support texture and graphical objects, obviously. Support and set all the controls. So mix and match filters, clamping and wrapping mode. So I mean, those are just in there. There's set methods for those texture nodes, like we can see here. And so I mean, it's just like what you think, just setting those filters. And I didn't want to mess with it anymore. So if it works the way we went over it, then it's good to go, I think. That's textures taken care of. Lighting, different types of lighting. So we've got, some shaders don't have lighting at all, and then we've got this guy, which uses the light color and light position in order to set that. So, in game.cpp, if we've got one that's, got one with light, texture light, we give it that color and we give it that position. And so right now it's just all even on it, but we can see that kind of working on that object. So if you look, for instance, at that green cube down at the bottom, or essentially the green or the duckweed, we can see that having an effect on it. You can see that as it loops back around. So we can set the light based on what this color and position vector are. So we've got the light shader for it, and we've got different lighting parameters. So you saw we've got 4 primitive objects. I've got a cube, I've got a pyramid, I've got a diamond, and I've got the ship. So like we saw, they can have textures, they can be drawn with lighting. I just created my own model. Small and vertex count, definitely. Textures, normals, vertices. So yeah, all of those follow the same vertex pattern, all those models. So, this guy, all that information. So position, UV, normals. And even though this data is in here, I do write these guys to file, but I just decide to leave that data in here in case if I end up changing something later, I'll be able to just quickly do so without having to remember what I did. So I've got one for writing to file, one for reading to file, and then I can just call the correct one based on some flag up here. And then later, if I want to, as you say, burn the ships, I can do that. Instancing capability. So obviously I've only got 4 models here, but I'm making 16 objects, so you can see me kind of calling, creating new graphic objects using the same model, S model, that's the ship, and then using the pyramid and the diamond and the cube. So instancing all of those in different locations with different transformations as we see as they're moving around in different lighting attributes. Yep. So 4 of each. I showed you moving the camera. Index triangles, as I showed you in the model class. So I've got my try list and my vertex list, and loading from file. So they are loaded separately, but as I showed, it is using that reading and writing files to do that and load it into those buffers. Write that data, and then loading it back in. 1 file per object. Loading in all those vertices, and then loading based on whatever the size of the file is. I've got my different shaders over here. We've got one in their corresponding graphic objects. So GLSL shaders, we've got const color, we've got a null one, we've got one for the original rendering, and then we've got one with those with the light calculations in there. Wireframe you saw in the demo, texture with flat, texture with point, yep. And scene graph using the PCS tree, that's taken care of in the game object manager. I've got my root tree that I can iterate through with things like finding a game object and just updating, looping through there. Transformation, yep. So for each of these, whenever we're doing transformations, we're just kind of going through and updating those so that they can send their information to what's being drawn. Multiple cameras, transitions, moving between just with that key press and the texture manager to create those guys and handle them and destroy it when they're done. So if we go to the texture manager, which is just called texture, I guess, then we can see we've got our active and then kind of our linked list, which we can iterate through. And then for all of these, these manager type things, I've got ways to get rid of them. So there's delete all textures. So at the end of the day, I can free these resources, and all that gets called in unload content down here. Delete textures, game objects, camera nodes, shaders, models, things like that. And having managers for all these things has made it a lot easier to clean up, so I don't have to worry about all those allocations. Freeing resources, so effectively this just means the way I interpret it is just once we're no longer using them, delete them. So that's going to take place at the end of the application. And here's just the video requirements. So I think I covered everything on here. And so let me just go back in here for just one more quick demo to show everything off a little bit. And so forwards, backwards, left, right, looping around. If I hit T, we're swapping the textures on all those guys. We've got 4 ships, 4 pyramids, 4 diamonds, and then 4 cubes. We've got our wireframes, our color with light, our regular color ones, our textured with lights, all these different shapes, all of it's taken care of and set in the game.cpp. This is done with instancing capability of the models. I only have a single one of those models that I load up. Actually, I broke everything into kind of mini functions because of this support. So here we see the camera creation, the camera nodes, which has of information, and here kind of building the linked list, GL settings. We just have one cube model, one pyramid model, one diamond, one ship that we add to the manager, loading the textures, loading the shaders that we go to the shader manager, and then we can call that creation and then just reference all this stuff like when we're trying to create all of our graphic objects and assign those to our game object instances that we're creating. Game object 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. And update, I broke everything out into little mini helper functions, so the update loop is relatively clean. I have processing input, with camera input, so those are all registering all those key presses for moving left, right, up and around, for switching the camera, and then things for processing texture input. So T, I update the texture objects, and then here's just kind of my transformations that I hacked together to show demo, and then the unload content. So I think that's pretty much it. I think I've covered everything that's in this document. Game objects, cameras, textures, lighting, input, instances, camera, loading from file, different rendering modes, scene graph, and attribute support. It's been a lot of frustration and a lot of fun, and I think I'm just about done. See you next quarter.